All right, let's get into it. Today, we're talking about a new player in the AI coding world that is seriously turning heads. It's called Qwen3-Coder-Next. And it's a fascinating story, really, because it's all about being smarter, not just, well, bigger.
Now, to really get why this is such a big deal, you've got to understand the landscape right now. It is, no joke, an AI coding arms race. We're talking about one of the most intense tech competitions on the planet. Billions of dollars are being poured in, and honestly, the entire future of how we build software is on the line.
And who's on this battlefield? Oh, just the absolute giants. You know their names, right? We're talking OpenAI, Anthropic, Google. These are the titans. They're all proprietary, closed source, with basically unlimited resources. They are the Goliaths here, setting a bar that seems almost impossible to reach. So, what happens when a completely new challenger decides to step into that ring?
Well, that's where our story begins. Meet Qwen3-Coder-Next. It comes from Alibaba's Qwen team, and believe me, this isn't just another model thrown onto the pile. No, this is an open-source underdog, and it's coming at this whole problem from a completely different angle.
So, what is this thing? On the surface, it looks huge, an 80 billion parameter model. But here's the crazy part, and this is the real key. It actually operates with a tiny, super lightweight footprint. It's built for what the experts call agentic performance. Now, what does that even mean? Think of it this way. It's not just a code completion tool that gives you a line or two. No, it's designed to act like a true autonomous assistant that can take on a big, messy, multi-step coding problem and just handle it.
And you know what really blows the doors wide open? It's open source. We're talking a permissive Apache 2.0 license. That means anyone, you, me, a solo developer hacking away in a garage, a researcher at a university, even a giant corporation, can use this thing, build on it, and even sell products with it for free. This is huge. It's basically democratizing access to a level of AI that used to be locked away.
Okay, so you have to be wondering, how in the world does an open source model go toe-to-toe with the Goliaths we talked about? Well, the secret isn't just throwing more computing power at the problem. It's all about a brilliant, incredibly efficient design. This is its secret weapon.
And this slide right here shows you everything. The old way, so-called dense models, that means all 80 billion of its brain cells or parameters are firing all at once, for every single task. It's powerful, sure, but it's also super slow and costs a fortune to run. Qwen, on the other hand, uses something called a mixture of experts or MOE approach. Here's the genius of it. Instead of asking an entire room of 80 billion experts for their opinion on everything, it's smart enough to say, for this specific Python problem, I only need to talk to these 3 experts over here. See the difference? You get the knowledge of the entire room, but the speed and cost of just talking to a few people.
And the impact of that, it's not small. We're talking a theoretical 10x higher throughput. What that means in the real world is it can chew through massive, complex coding tasks, like understanding an entire software repository 10 times faster. That is a gigantic leap. It means you can solve bigger problems way, way faster.
But wait, there's another villain in our story that plagues almost all big AI models. It's called the memory wall. Here's the problem. As you give a model more stuff to think about, like, say, your entire company's code base, it doesn't just get a little slower, it gets exponentially slower. The costs just spiral out of control, making it basically impossible to work with really large projects. So how does Qwen deal with this? It tackles it head-on. First, it has a massive context window. We're talking over 262,000 tokens. That's a huge amount of information it can hold in its head at once. Then, it uses this really clever hybrid architecture. The combination of these two things just smashes right through that memory wall. The result is wild. It can read and understand a massive, complicated codebase with the speed of a tiny little model, but with the deep comprehension of an absolute giant. Okay, so having a brilliant architecture is one thing, but that's only half the story. How this model was trained is just as revolutionary. See, it wasn't just force-fed a bunch of code from the internet. No, it was actually trained to think and to act like a real-world software developer.
And the sheer scale of this is, wow. The team built a pipeline of 800,000 real, verifiable coding tasks. And we're not talking about Hello World examples here. These were actual, nitty-gritty, bug-fixing jobs, pulled directly from real GitHub projects. The messy stuff.
So here's the magic loop.
First, the agent would try to write some code to fix one of those real bugs. Then, that code was immediately put to the test, run in a live, safe environment. Did it work? Did the test pass? If not, the agent got instant feedback, learned from its mistake, and then tried a different approach. It learned by doing, failing, and trying again. Exactly how human programmers learn.
And this quote from the Qwen team's technical report just nails it. They said, scaling agentic training rather than model size alone is a key driver for advancing real-world coding agent capability. What they're saying is, the secret sauce isn't just making the model bigger and bigger. The real breakthrough, the thing that actually moves the needle, is making the training process itself smarter, more active, more like the real world.
All right, so the theory sounds amazing, right? A super efficient model trained like a real coder. But the big question is, does it actually work? Let's put some numbers on the board and see how this thing really performs. Okay, let's look at SW Bench. This is a really tough benchmark that tests how well an AI can solve real-world software engineering problems. And look at this. Qwen3-Coder-Next scores a very impressive 70.6%. It's right there, neck and neck with the big dogs. And remember the secret weapon? It's doing all of this while only using a fraction of its total size. It is absolutely punching above its weight class, delivering heavyweight results from a lightweight engine.
But this next one is where my jaw kind of dropped. When you look at security, actually finding and fixing security holes in code, it doesn't just compete, it actually leads the pack. It pulls a 61.2% on this security benchmark, which is significantly better than a major closed-source competitor like Claude Opus. And looking at it on a bar chart really drives it home, doesn't it? That is not a small gap. This strongly suggests that its unique training method, that whole loop of coding, testing, and learning from real bugs, has made it way better at spotting security issues. It's like it's been trained to think defensively, making it a much safer coding partner out of the box. So let's zoom out for a second. What does all of this mean? What happens when a model like this gets released into the wild? Because this is way more than just another model dropping. This feels like it could be a real turning point for the whole industry. So why should you care? Well, first, because it's open source, it means these incredibly powerful agentic tools are now available to everybody. It democratizes this stuff. Second, it's a huge proof point that you don't always win by just being bigger. Smarter architecture and smarter training can beat raw size. And third, it really shines a spotlight on what the next big challenges are, cracking the code on infinite context and blazing fast speed.
This really feels like a potential shift in thinking. For years, the mantra in AI has been bigger is better. Just build these massive, monolithic, mammoth models. But what if that's not the future? What if the future is actually a collection of these ultra-fast, lean, specialized, expert models that are just as powerful, but also accessible to everyone? And that leaves us with a really fascinating question to think about. With a model out there that's this efficient, this powerful, and this open, could we be looking at the beginning of the end for the era of the Mammoth AI? Is the whole bigger is always better philosophy about to be replaced? Maybe the age of the sparse, efficient expert has just begun.